Welcome to the Explainer. We're jumping right in today, taking a highly focused look at the SASB Sustainability Accounting Standards, specifically those tailored for the oil and gas exploration and production sector. If you want to really understand how the biggest players in energy are quantifying their true impact, you are definitely in the right place. We're going to break down the literal math and the strict methodologies used to report on two absolutely critical risk areas: environmental biodiversity and workforce safety. Here is our game plan for today. We'll start by decoding the SASB sustainability metrics, then look at how we measure biodiversity and spills. After that, we'll track protected conservation reserves, calculate workforce safety rates, and finally, wrap up with the real value of standardization.
All right, Section 1, Decoding SASB Sustainability Metrics. Let's get grounded.
To start, we have to anchor ourselves in the actual framework guiding these global disclosures. The International Sustainability Standards Board, or the ISSB, oversees these SASB metrics to ensure that what a company reports actually gives investors a clear, uncompromising picture of their operational risks. We are not talking about some vague, feel-good corporate pledge here. This is rigorous quantitative accounting. We're dealing with specific accounting codes and exact units of measure, like metric tons, hard percentages, and standardized incident rates.
Moving right along to Section 2, Measuring Biodiversity and Spills.
Let's look at the first half of our risk equation, the environmental impact. In the E&P industry, managing and reporting hydrocarbon spills is huge, and the parameters for what counts are incredibly strict. We are talking about any spill greater than 1 barrel, which is 159 liters. It only counts if it actually hits the environment. So, if it was caught by an impermeable secondary containment system, it stays off this specific metric. But here is a really fascinating, absolutely crucial rule: your aggregate volume is not reduced by the amount you later clean up. If you spill 100 barrels and manage to recover 90, you are still reporting a 100-barrel spill. It's a brilliant rule because it ensures total transparency about the scale of the initial hazard, completely regardless of the cleanup effort.
Section 3, Tracking Protected Conservation Reserves.
Beyond the sudden chaos of a spill, entities also have to report on a much more permanent footprint, where their actual physical assets are sitting in relation to highly sensitive ecosystems. And SASB doesn't leave protected area up to interpretation either. A site only has protected conservation status if it falls under internationally recognized designations. We're talking IUCN protected areas, Ramsar wetlands, UNESCO World Heritage Sites, Biosphere Reserves, or Natura 2000 sites. If an oil and gas company has reserves that overlap with the habitats of species listed as critically endangered or endangered on the IUCN Red List, that gets flagged immediately.
Now, you might be wondering, what does it actually mean to be near one of these sites? Well, proximity has a hard quantifiable boundary. Near is strictly defined as being within exactly 5 kilometers of that recognized protected boundary. This 5-kilometer buffer zone is vital because, let's be real, environmental impacts like noise, air emissions, or water runoff don't just magically stop at an invisible property line. So entities have to calculate and disclose the exact percentage by volume of both their proved and probable reserves that fall inside these 5-kilometer zones. What does this matter so much to a savvy investor? Because reserves located in ecologically sensitive areas face massive regulatory barriers, intense community scrutiny, and potentially astronomical extraction and cleanup costs. In certain areas, like the Arctic or delicate mangrove swamps, those factors could fundamentally tank the future value of those reserves.
Up next, Section 4, Calculating Workforce Safety Rates.
Let's pivot from environmental health to human health. We're looking at inherently harsh operating environments, heavily reliant on contractors, making standardizing safety data incredibly important. There is a very strict dividing line here. A total recordable incident, or TIR, is logged when there's actual harm: death, days away from work, restricted work, loss of consciousness, or medical treatment that goes beyond just a basic first aid kit. On the flip side, we have the near-miss frequency rate, or NMFR. A near miss is an unplanned event that had the clear potential to cause physical or environmental damage, but luckily no one was actually hurt. Tracking those near misses is just as critical as tracking actual injuries because it exposes the weaknesses in process safety before real tragedy strikes.
To calculate either of these rates, we use a standardized constant across the entire industry, the number 200,000. Now, that sounds totally arbitrary, right? But it's actually highly specific math. It represents the exact number of hours that 100 full-time workers working 40 hours a week for 50 weeks a year will provide annually.
It's simply the standardized baseline of human operational hours.
Applying that constant gives us the exact formula required by the standard. Step 1. You count the statistic, so your total number of recordable incidents or near misses. Step 2. You multiply that count by our 200,000 constant. And step 3. You divide that result by the total number of hours actually worked by all employees during the year. This elegant little formula creates a perfect apples-to-apples comparison across totally different companies, regardless of how massive or tiny their workforce is.
Finally, Section 5, the value of standardization. So why do we go through all this? Why obsess over a rigid 5-kilometer rule or the exact definition of first aid? Because what gets measured gets managed. As the standard specifically calls out, an entity's ability to effectively manage these exact risks directly prevents accidents, mitigates massive costs, and reduces operational downtime. By standardizing both environmental and safety metrics, these companies can actively manage their cost of doing business. A strong culture of safety and careful biodiversity management isn't just about good PR. It is quite literally a fundamental roadmap for operational efficiency.
Which leaves us with a pretty massive question to look forward to. As environmental constraints keep tightening and safety expectations keep rising globally, how will these standardized metrics actually reshape the valuation of oil and gas entities in a climate-conscious future? When you apply these standards in your own analysis, ask yourself how this level of radical transparency, knowing exactly how many barrels spilled, exactly what percentage of assets sit in protected zones, and exactly what the incident rate is, will ultimately shift the balance of investment power in the sector. Thanks for joining me on this deep dive in the Explainer. Keep questioning the data, and I'll catch you next time.